Hello everyone, my name is Osma and I come from the National Library of Finland. My topic is extracting metadata from grey literature using large language models. So first of all, what is grey literature? It's different kinds of documents like reports, working papers, government documents, preprints, theses and so on. These are usually semi-formal, non-commercial PDFs published on the web, and there are lots and lots of them. So why would you want to extract metadata from these? One use case is to help users of digital repositories who need to enter metadata when they upload PDFs to the system. And the second use case is to get more information about harvested PDF files when doing web archiving. And the third use case is to ease cataloging of, for example, government reports and doctoral theses that need to go into bibliographic databases. But why is it hard to extract metadata from PDFs? Well, many PDFs contain embedded PDF metadata, but you can't really trust it. Here are some real examples of document titles extracted from PDF metadata. They don't make a lot of sense. So you also have to look at document text. But the text is created using diverse templates and very creative text layouts. And in general, PDF text extraction is very messy and unreliable, so you get artifacts like the ones here on the slide. Okay, so we've been looking at this for some time now, and here are some early experiments. In 2019, we tried a tool called Grobid, but it didn't work very well with the grey literature we had, and probably because it's mainly intended for scholarly papers, but we had other types as well. Last year, a company called Linksoft made a prototype for us using PDF text extraction and traditional machine learning. We were not super happy with it, but yeah, it was a nice prototype anyway. And then at the beginning of this year, we did a quick experiment using the OpenAI GPT-3 fine-tuning API. Here's the link to the GitHub. So the idea here was to try to use a large language model to try to predict metadata based on document text. So we took the first few pages of text from each PDF and we gave it to the language model and we fine-tuned it and tried to aim for a representation of the metadata that looks like this, so it's Dublin core style fields and values. And here's an example of how the result looks. This is a diff view, so it's a comparison between the original human-generated metadata and then what the language model produced. So the human one is in red and the machine-generated is in green. And mostly they agree, so the model produced almost the same result. There's a little mistake in the title and also the date is wrong, but other than that it was pretty good. So what we found out in this experiment was that this extraction using LLM could actually work, but one problem we had is that we need more consistent ground truth metadata for the grey literature. And we also probably don't want to rely only on this OpenAI API because of many reasons. It's proprietary and so on. To help with the data issue, we created a dataset called FinGreylet. So it's PDFs and corresponding metadata collected from 9 different DSpace repositories. So these are repositories are used by academic libraries and government institutions, and they contain many kinds of documents. In total in this dataset we have currently around 700 documents. We had a summer intern do some curation to try to align the metadata so because the different repositories had different metadata practices to try to make it more harmonized. And now we have Dublin core style metadata with around 30 fields in use in total, and it's in 3 languages. And it's in GitHub, so if you want to take a look. But it's still work in progress. Here's how it looks in GitHub. So there's some documentation and statistics and documentation there. And now using this dataset, we have been doing some new experiments. First of all, we tried the Meteor tool, which was very recently published as an open source tool by the National Library of Norway. Here's the link. And it's a very nice tool. It's rule-based, so it's not based on language models, and it can extract 7 fields. And we've done some other experiments using GPT-3 and Llama, and we want to do Finnish GPT-3. But no results yet, so I will tell you more when I have something. Thank you.